Voyager 2, an interplanetary probe that was designed to observe and transmit information back to Earth about our solar system's largest planets. Equipped with a payload of scientific instruments, the probe provided scientists with a wealth of data, allowing us to explore the mysterious gas giants like never before. Launched in August 1977, Voyager 2 and its twin Voyager 1 took advantage of a rare planetary alignment that takes place every 176 years, providing the opportunity to fly by Jupiter and then Saturn. Unlike its twin, Voyager 2's designed trajectory meant that the probe was also able to continue to Uranus and Neptune, becoming the first and currently only spacecraft to visit the solar system's outer planets, the ice giants. Voyager 2 passed the mighty Jupiter in July 1979. Nearly 2 years after it was launched, and captured incredible images of the gas giant and its many moons. Then, in August 1981, the probe arrived at Saturn, transmitting back many more spectacular images of the planet's magnificent rings, atmosphere, and moons. It would take another 4.5 years of travelling through the cold, dark expanse of space, however, before we would get the first close-up glimpse of the mysterious Uranus. In January 1986, Voyager 2 made its closest approach to Uranus, observing the mysterious planet's fascinating features, such as its moons, rings, atmosphere, internal structure, and magnetic environment. At this point, Voyager 2 was around 1.8 billion miles away from Earth, which is around 2.9 billion kilometers away and nearly 10 years into its historic mission. During the flyby, the resilient probe discovered 11 new moons, all of which were named after Shakespearean characters: Puck, Portia, Juliet, Cressida, Rosalind, Belinda, Desdemona, Perdita, Cordelia, Ophelia, and Bianca. We were able to see spectacular close-up photos of moons that we already knew existed in orbit around Uranus, including Miranda, a moon with a jumbled-up surface that appears as though it was pushed together and then broken apart several times. 4 other large moons were also closely photographed for the first time, allowing us to observe Oberon, Ariel, Umbriel, and Titania, revealing their amazing geology. As Voyager 2 completed its short flyby, it studied the Uranian rings, 9 of which were already known to exist, and 2 newly discovered by the spacecraft. The rings turned out to be distinctly different from those found circling Jupiter or Saturn, and may be relatively young, likely not forming at the same time as Uranus. One theory is that the particles that make up the rings may be the remnants of ancient moons that collided and broke apart. Observing the Uranian atmosphere, Voyager 2 sent back photographs of a mostly featureless light blue planet. But it did record wind speeds as high as 450 miles per hour, which is 720 kilometers per hour, and found evidence of a deep, icy ocean. But this strange, icy ocean isn't as we understand it here on Earth. Instead, it would be a highly pressurized, hot, dense fluid consisting of water, ammonia, and other substances. Data also revealed that the atmosphere is similar to Jupiter and Saturn, being mainly composed of hydrogen and helium, but also methane, making the planet a beautiful light blue. Scientists had already discovered that Uranus was tilted on its side by 98 degrees before Voyager 2 had arrived there, possibly as a result of an ancient catastrophic collision. However, the the spacecraft did detect another bizarre feature on the ice giant, its mysterious magnetosphere. The Uranian magnetic field is tilted by 59 degrees from the axis of rotation and does not pass straight through the center of the planet like many other planetary fields. This unusual arrangement creates an irregular field, and even today, scientists are unsure of what is causing this strange, non-uniform phenomenon. Voyager 2 came within 51,000 miles, or 81,500 kilometers of the ice giant's cloud tops, allowing the incredible probe to study the mysterious planet for around 5.5 hours during the historic flyby. Then, in February 1986, the spacecraft performed a maneuver called a gravity assist that propelled it into the direction of the next and last planet in the solar system, the magnificent Neptune. Like Uranus, Neptune had never been visited before, and so Voyager 2 would become the first ever spacecraft to pass the distant blue planet. In August 1989, after a journey that spanned 4.3 billion miles, or 7 billion kilometers since it left Earth, the ambitious probe arrived at its last planned destination. During the flyby, Voyager 2 found 6 new moons that were later named Proteus, Larissa, Despina, Galatea, Thalassa, and Naiad. But it also photographed other already known moons, such as Neptune's largest, Triton. Triton was revealed to be not only the most intriguing natural satellite in the Neptunian system, but one of the most interesting in all of the solar system. These incredible images present a bitterly cold moon with a remarkable geological history, and even show an active geyser-like eruption spewing invisible nitrogen gas out into space. Triton's relatively high density and retrograde orbit also offer strong evidence that the strange moon is not an original member of Neptune's family, instead a captured object from somewhere else. As Voyager 2 passed Neptune at just 3,000 miles, or 4,800 kilometers above the ice giant's cloud tops, the spacecraft detected a highly active atmosphere, with wind speeds far exceeding 680 miles per hour, which is 1,100 kilometers an hour, the fastest detected during the entire journey. Like the other gas giants, hydrogen and helium were found to be the most common elements, although the planet's magnificent cobalt blue appearance is once again due to the presence of methane. Originally, it was thought that Neptune was too cold to support atmospheric disturbances. However, Voyager 2 discovered large-scale storms. The largest was named the Great Dark Spot. This hurricane-like storm was about the size of Earth at the time and similar to Jupiter's Great Red Spot. But Neptune's massive storm didn't seem to last very long, at least by giant planet standards, as just 5 years later the Hubble Space Telescope revealed that the Great Dark Spot had already dissipated. Voyager 2 also photographed 4 new rings, and revealed why Neptune's ring system is so faint, mainly because of the fine material that it's made up from. It confirmed that all of the solar system's gas giants have rings, and that none of them are as spectacular as Saturn's, although they are all fascinating in their own way. After 12 years in deep space and successfully exploring all 4 of our solar system's largest planets, Voyager 2 had finally completed its initial mission. The amazing spacecraft studied different aspects of the gas giants and allowed scientists to solve many of their mysteries. But the grand tour of the outer planets had now come to an end. Neptune was the last close encounter Voyager 2 will make for possibly millions of years, but it will come relatively close to certain stars in the future as it silently drifts through interstellar space, the place that it's currently exploring. After 43 years in space, Voyager 2 is still making discoveries, etching itself into the history books as one of the greatest and most resilient spacecraft ever to leave our planet. An achievement that all of humanity can be proud of. If you would like to learn more about where Voyager 2 is predicted to be heading next, then check out the video at the end where you can follow its journey out of the solar system. I hope you enjoyed this video, however, and if you did, then please hit the like button, subscribe, and let me know in the comments section which of the discoveries is your favourite. Thank you so much for watching, and I'll see you next time.